Hello everyone and welcome back for the MARRES Symposium 2022. We are this afternoon with the last session, session number 5. And in this session we will mostly talk about human insights and ocean. We'll have the pleasure to hear Aurore, Clara, Angela and Megan will be remotely attending and participating to the symposium. I would like first to officially thank the different members of different reviewers of the master thesis of this session. So thank you, Christina Varese, Nathanaël Guigaud, Robin Fayetaz, Guillaume Chandelier, François Seneca, Eric Rottinger. And for today, it's my pleasure also to introduce you to the different members of the jury. That you have so in front of you, but also with distance. So thank you, Eric Rottinger from Université Côte d'Azur IRCAN, Robin Fayetaz from Ifremer at Lorient, Cristina Giovanna from the University of Torino, Aldi Daniel from Université Côte d'Azur IRCAN as well, and Jean-Vincent Joingrassa for the eyes from a high school teacher in biology and an active member from Nature Dive. Robin, do you hear us correctly? Yes, good. So we will start with Aurore. Aurore, do you hear me also?
Yes, I do. Hello, everyone.
It's all good. Can you try sharing your screen, please?
Sure.
Talk about the assessment of marine litter and plastic pollution in the coastal waters of the Eastern Mediterranean.
Can you see my screen?
Yes, I can see your screen. Alors, Aurore, do you have a timer for the 15 minutes in front of you?
I do.
Okay, so you're going to have 15 minutes of presentation, and after this, something like 20 minutes of questions. We can see your screen, so if you're ready, you have the floor.
Well, good afternoon, everyone. I'm happy to present to you my master's thesis presentation about marine litter and plastic pollution in Limassol Bay, which is located in the Cyprus Island in the Eastern Mediterranean Sea. I conducted this research work with MARRES, the Marine and Environmental Research Lab, which is a governmental consultant in marine research in Cyprus. For this presentation, I'll be following the scientific outline. I'll begin with an introduction, then I'll go through the materials and methods, then I'll discuss about the results and discussion, and I'll finish with a conclusion. But first, I would like to give you some background information about plastic. So plastic production have been continuously increasing so far, and here we can see in this graph in blue how much Europe have been participating to this production. So plastic is now known in a lot of sectors, and packaging is largely in the lead, corresponding to more than 40% of this worldwide plastic production. So plastic is now ubiquitous and persistent in the environment, and it is harming marine life in many various ways, such as entanglement, for example, where marine species can get stuck in lost fishing gears, as we can see here. It can also cause ingestion when animals take the plastic as food, or they're just being curious. It can also cause the introduction of invasive species when species stick to marine debris and are transported along long distance over seas and oceans. So more and more we hear about microplastics in the recent decades, but what are these exactly? Well, microplastics are plastic particles smaller than 5 millimeters in length. They can have two different origins, primary or secondary origins. Primary microplastics are tiny microplastic pieces already created this way by manufacturers. So they are already smaller than 5 millimeters, and we can find them, for example, in deodorant beds, or they can be pellets that are often lost during transport. However, secondary microplastics are originated from the breakdown or larger material of plastics. Plastics are non-biodegradable in the water, but they eventually break down due to the wave action and the weathering in the ocean. So those tiny pieces represent a challenge in our environment, and due to their very tiny length, they are very hard to eliminate from the environment. So in this study, I conducted a research work in Limassol, which is the second biggest urban area of Cyprus in the Eastern Mediterranean Sea. More globally, the Mediterranean Sea is considered as an accumulation zone of plastic debris due to its morphological and hydrodynamic characteristics. And it is also known as one of the most polluted seas in the world. So moving on now to the material and methods of my study. Well, I selected 3 anthropogenic pressures. It is known that more than 80% of marine debris are originated from land waste, and those waste on land are transported through rivers and rainwater outlets to end up on the beach and on the marine environment in general. So 3 rivers and 3 rainwater outlets have been selected. And I also add ports in the design, since they're also considered as accumulation zones from maritime activities. Moreover, I added 3 controls to accurately compare those 3 pressures to more remote sites that are located away from any of those 3 pressures. So as it is known that rivers, rainwater outlets, and ports, as known as accumulation zones for plastic debris, it is expected in this world that more marine litter and microplastics will be found near those pressures. So now let's talk about the sampling design of this study. Here you can see an aerial pictures with all my different locations sampling sites. So there are 12 different sites corresponding to the 3 controls, the 3 rivers, the 3 rainwater outlets, and the 3 ports. And 3 main analyses have been done during this study. So first, the marine litter recording. So I've been walking in zigzag through a 100-meter long transect and recording marine litter according to a joint list of category of large microplastics. And this list have been designed by the Marine Strategy Framework Directive in 2019 in Europe. Then, in the meantime, I collected microplastics with 2 different methods using a large quadrat of 50 by 50 centimeters and a smaller quadrat of 20 by 20 centimeters to collect then small microplastics. But why have I used 2 different methods? Well, so the first method I've been proceed with a sieving method. So the sediment have been sieved through a 1 millimeter size mesh, and then they have been then sorted according to their types. That can be fragments, film, fibers, foam, pellets, and the category suspected has been added when they were not corresponding to any of those previous types. And I realized on the field that there were some debris that were larger than 5 millimeters, but still considered being breakdown from larger materials. And that's why plastic debris have been counted even being bigger than 5 millimeters, going up to 40 millimeters. And I call them large microplastics. However, another method has been used to stick strictly to tiny pieces less big than 5 millimeters with a sediment filtering method. So I used a vacuum filter, and all microplastics have been gathered on filters and then observed with a stereoscope. So moving on to the results now. Well, 100% of all sediment samples were contaminated by microplastics. And this is also the case for the macro litter, where more than 60% of all the litter were plastic. So among those plastics, the first more abundant plastic types have been hard plastic fragments. Then the polystyrene pieces were in second position. Then foam pieces were the third more abundant. And cigarette butts and plastic lids were just following. Now for more details for the macro litter. Here we can see on this bar plot that rivers are containing the highest number of litter items. So here, by far, we can see that this bar plot is way higher, and more than 1,500 number of litter items have been identified. And we can also see from this bar plot that plastic, being represented in light blue here, is being found in the highest proportion at all pressures. But it's important to take those results with caution, since sites were heterogeneous. Here we are comparing the CCI numeric values. So CCI is the Clean Coast Index, which is an indicator that assesses the beach cleanness. And a higher value corresponds to a dirty beach. So here we can see that Port 1 and River 1 are really different, that they're two different respective sites. This Clean Coast Index also allows to establish scores and colors, and that's why we have designed a heat map. So a blue color corresponds to a very clean beach, green to clean, yellow to moderate, orange to dirty, and red to extremely dirty. And here on this map, we can see that most of the orange and red colors is concentrated in the city center of Limassol, which is a clear sign of urbanization pattern. And moreover, we've seen that there were significant difference in the CCI mean of all pressure types, and rivers have been found to be the most contaminated sites. Now, for the density, a density of 0.59 items per meter squares have been observed. And this result is alarming, and it's actually higher than what we can find in the literature regarding the coastal areas of the Mediterranean and even Cyprus. A really recent study of Orthodoxo and al. Found an average density of 0.15 items per meter squares. But they did assess the whole coast of Cyprus, whereas I only focused in this urban area of Limassol, which could explain why I found a higher density. Now, moving on to the microplastic findings. Here on the left, we can see the small microplastic findings proceed with the filtering method, and here, the large microplastics that have been proceed with the sieving method. Let's precise first that the scale is a bit different between those two graphs. And large microplastics have been observed, but it's also because they have been proceed in larger surface, larger quadrats. Here we can see, compared than before, that the controls are the highest contaminated site compared to the other pressures. And we can also see that a statistical significant difference have been observed compared to the different types of microplastics. Indeed, here we can see in orange that fibers have been found in a higher quantity than any other types of microplastics. This finding has been also confirmed in the literature, where fibers are the most predominant form of microplastics in the ocean. However, for the large microplastic, there's no such assets. However, we can still see that foam and fragments in green and orange seems to be higher for controls and rainwater outlets. Now, regarding the density of microplastics, I found an average of 181.3 items per meter square and a maximum value of 500 items per meter squares. This alarming result is actually lower than what have been seen in Greece, which is really near Cyprus. Cabere and al. Found 300 items per meter squares. But it's important to say that this study has found some sites without any contamination of microplastics. And this is not the case here. In this study, all the sites were contaminated. I also want to add that it was hard to compare my values with many other studies, since there is no standardized protocol of microplastics so far, and I found values in kilograms of plastic or in cubic meters, but not so much in items per meter squares, and there's a need to standardize those values to accurately compare studies internationally. So to conclude, we've seen that macrolitter was closely associated with a coastal urbanization, and this validates the hypothesis. There is a clear influence of rivers and coastal modification. We also found that rainwater outlets and ports were also higher contaminated than the controls. However, for microplastics, we can't accept the hypothesis because their distribution is highly variable and not associated to any pressures. And this suggests that other parameters should impact their repartitions, such as currents or beach orientation and wind. And more research work should be conducted to model their transport. So at the end, there is no link between the distribution of macrolitter and microplastics. And finally, I would like to finish this presentation with some remediation strategies, since plastic is now on the top 5 of the major threats on the marine biodiversity. There is a great need to educate the general public and raise awareness, and this goes through the implementation of consistent campaigns and citizen and participative science. Recently, I participated to a beach cleanup in Cyprus, and I've been amazed to assess how much local people were happy to raise more awareness and bring more and more volunteers every year to remove the litter on the sea. There's also a great need to standardize microplastic protocols. For the macro litter, we've seen that there were lists in Europe that were established already to conduct studies across all Europe. But for microplastics, there were so many different methods used in the literature, and also the way to present the results were different. And finally, individual behaviors can definitely make a great change. If we would already all reduce our consumption of plastic, that would help to protect our oceans. So I would like to thank MARRES for all the field work, lab work, and desk work they provided me during this 6 months internship. I particularly thank Dimitris Kletus and Yannis Sava for helping me conducting this research work. And I thank you, the jury, for your attention. And I let the floor now for the potential question you may have and the discussion. Thank you.
Thank you, Aurore. Thank you for your presentation and for staying just on time. Let's open the floor for questions. You're right. Who would like to start? First, we can start here. Aideen, for example.
Okay, yeah.
Yes.
Hi, Aurore. Thanks for your nice presentation. So in your introduction, you mentioned that you selected 3 anthropogenic pressure.
Yes.
So could you define what, in the context of your study, you are naming anthropogenic pressure?
Well, can you see my slide first?
Yes, just a second.
Well, you mean how do I consider those pressures to be anthropogenic?
How do you define anthropogenic pressure?
I would say that it's created by human, and that's a modification of the coastline.
Okay, so here you show us 3 different sites where you collected. So I didn't see the link between these 3 anthropogenic pressure and the site you were showing us. So can you just clarify this slide, please?
Sure. Well, for the rivers, I sampled my results in 3 different rivers, but they were actually heterogeneous in the sense that Garilis rivers and Vathias were flowing while sampling. However, Amathos River were dry, for example, and that already make a change. For the 3 rainwater outlets, the 3 larger pipes have been sampled along the coast. And for the ports, Limassol port were the bigger one, but Limassol Marina and Saint Raphael Marina were smaller ports containing mainly sailboats and yachts. And that's what we can see on the sampling, the aerial picture here. They are all kind of well spread along the coast, and that has been done on purpose, actually, to also, I was also interested at the beginning to see if there was any gradient, since all those all those sites are approximately equally spread.
Okay, so you mean that you selected 3 different sites that can have anthropogenic pressure on them?
Exactly, and
okay.
we selected 3 rivers to have a representativity in this study. That's why 3 of each were selected.
Okay, and how did you choose your control site and which one were there?
So the control sites have been selected away from those pressures. So it was hard to find those sites because first I had to find sandy beaches. We only sampled sandy beaches, the sediment. And so this control site was easy to find because it was, well, far away from the city center. And this one as well, but control 2 was a bit more tricky, but it was still located away from any other pressures. And that's why it has been selected. It's also, in Limassol, there are some, well, the city center is here, and there is also urban area here, but in the middle, there are ruins that are archaeological sites that are protected, and it is less urban, let's say. So that's why the control 2 have been located here.
Okay, thank you. So you talk in your conclusion, I think that you were talking about this no link between the distribution of the microliter and the microplastic, but you mentioned also in your methodology that you did not prospect and collect it in the same surface area. So how can you compare your data?
Well, this is true because it's impossible to sample the whole sediment on a bit of a beach, which is not the case for macroliter, but it's already representative since it already gives a result of a number according to a surface, and the clean coast index that has been used for the macroliter is actually an index that takes in consideration the surface area. So each surface were equally proceed in that sense.
Okay. Regarding your ICC index, so which kind of criteria they are using to develop it?
Well, they use the surface area of the beach. So we analyzed the surface of each beach, and then it counts all the numbers of items detected, and it gives then a value of cleanness according to this surface and the number of macroliter that have been found.
Okay, thank you.
Sure.
Who wants to go next?
Hi, thank you for your presentation. About the strategy of the choose of the control sites, you talk about the terrestrial parameters such as the urbanization, for example. And did you take into account marine parameters such as the currents or something else?
Well, this has not been considered, but this is why more research work should be conducted in that sense, because we actually see in this study that controls are the most contaminated sites. So we can clearly see that there's no distribution that is linked with any pressures, but so something else should be causing this distribution, and that is probably, most probably, the current. So that's why I was mentioning that the transport of microplastics should be further analyzed in this work to see how much the current is contributing to this distribution along the coast.
Okay. And how did you create the random method? The
random chosen point for the quadrats, you mean?
Yes. It's your choice?
Or no, it's 3 random points along 100 were selected with an app on my phone.
Okay. And regarding the literature, there are a lot of study about the microplastic and the presence, etc. And what is new in your study?
Well, which is new is that it has not been done in Limassol so far. There are no microplastic findings along the coast. So that gives already a value and a number of items that can be detected.
Okay, thank you.
Thank you. Eric, Robin, Christina, who would like to go first?
I can continue.
Eric.
Yeah.
Okay, Eric, then Robin, and then Christina. I propose.
I have so first of all, thanks for the clear presentation, Aurore.
Thank you.
You showed that the 3 rivers. I think you sort of mentioned the answer to my question in Aldine's answers. But so why were the 3 rivers different in terms of results of the macropollutants? That's because one was completely dried. out, right?
Yes, that's a very good point, and that's a limitation on this study. I was not able to find more. Well, I had to find 3 rivers to correspond to the rest of the study, where 3 sites were corresponding to each pressures. So I had to find 3 rivers, and there were no more rivers than those one, and that's why I still considered Amatos, which is mostly, well, it's like 6 months flowing in Cyprus, but as the rain regime is really poor, most of the times it's dry, and it was dry when I was sampling the area. So that's a limitation. And also for the ports, which are all different. The Limassol port is clearly bigger than the 2 others sampled. However, for the rainwater outlets, they were approximately similar. They were all looking similar to each other.
So will there be a follow-up study from what you did on the sampling site, but when all 3 rivers are flowing, just to be able to compare those 3 rivers?
That would be very interesting to sample more during the winter season, where all the rivers are flowing. And for the follow-up as well, that would be also interesting to conduct this study on the sea. It was actually planned to collect microplastic pieces with a net around those pressures to see the impact and repartition of plastic on the surface area. But we realized that in this 6 months internship, it was impossible to conduct this work. It was already a challenge to finish it on time with only sediment samples. But it would be planned to continue that way.
Okay, and then coming back to the ports, I understand that the rainwater outlets and the rivers are sort of a source of pollution. I didn't really understand the harbors or the ports. Is that a source of pollution or a trap of pollutions?
They are considered in the literature as accumulation zones from maritime activities. So I added them in the design because they're considered as anthropogenic pressures, since it's a source of plastic and marine litter in general. Okay,
and then I have 2 questions, or one. You talked about the importance of standardizations. I hear this in the macroplastic field since several years. So is there an international effort that you are aware of where people try to standardize this? Because I think that's a real big issue in the field, where everybody sort of comes up with their own metrics, and so you can't compare anything.
Yeah. Well, so what's the question exactly? Do I think that
if you know that there are some international efforts, because I believe that the microplastic marine litter community is quite big around the world. So if you know some initiatives of standardizing.
Well, so far for microplastic, it is clearly lacking, but there are some more precise work that are using spectrophotometry, for example, to clearly identify all the polymers of plastic. And those findings are more precise, and I had no access of such equipment. But I know that for those kind of studies, the results are obviously presented in the same way. So that's already a good point. But for a visual census, as I did, I am not aware of any standardized protocol so far.
Okay, I leave the floor because there are 2 more.
Yes.
Thanks a lot.
So I propose Aurore and Christina.
Thank you all for your presentation. My question is a bit in line with Eric's. Do you have any, so I know you cannot identify precisely, but do you have any idea of the sources of the origin of the microplastic that you have, and from what they come from, and which one, whether like they are more persistent, some may be biodegradable, biodegradated over time by staying at sea? And do you have any idea whether the sources are only inland or they can be also coming from the sea?
Are you only talking about macro litter or microplastics as well?
Microplastic, most of them probably come from macro litter. Yeah, I assume.
Well, yeah. Well, for macro litter, sometimes we're lucky enough to assess some packaging, and we can actually easily know the source. We found some packaging that were from Lebanon on the coast or Turkey. But when we're not able to see clearly on the packaging where it does come from, yes, it's known that 80% of those debris come from land, but there's still a huge amount coming from the sea itself with the ship activity. And for the microplastics, there are also colors that can be an indicator of where do they come from. When they come from a bigger material, we can sometimes put some assumptions on what was the material. Same for the different types. Most of foams are created for the insulation of in the construction sector. So we can assume some of those origins.
So you think so? Just if you may not have the I mean you don't have the answer because you cannot have it. But do you have an idea of what use or usage, like for example the construction, leads to the most of the microplastic that you're finding there in the area you studied?
Sorry, I didn't get the question.
Do you know what usage? So I'm thinking, like you just say for the foam, it probably comes from the construction. The microfiber, I think it's probably difficult to assess. But like for the do you know if there's some activities in particular that may lead to this relatively high densities of microplastic that you found, or it's just like human usage in general? Like
I feel like all the different types can be come from the different sectors. I know that in Limassol, the construction sector is evolving in the recent years, and that's maybe why we found so much polystyrene and foam plastics on the beach.
And so the next question would be, how would you try to identify these sectors or these activities that lead to high amount of microplastic?
Well, it would be great to do a gradient of like how much the construction sector, if we're talking about it, can impact the coasts. That would be great to see how much those wastes originating from this sector would spread into the environment.
Thank you.
Thank you, Robert. Christina?
Thank you.
Aurore, thank you. Thank you for your presentation. It has been really very nice also to read your thesis. Most of the question or curiosity has already been asked my colleague, but now I would like to ask you from a practical point of view, which kind of suggestion or activities you would like to carry out at local level to try to decrease the impact of the anthropogenic the impact of the anthropogenic source on macrolitter and microplastics. So really from a practical point of view, what you would suggest to the local authorities?
Well, first, I think that beach cleanups are clearly changing. It's a really great initiative to at least remove waste that we can find on the coast. That is already really positive. And on the beach cleanup I did, local people were telling me that they were assessing less and less plastic debris every year. But as it is a growing threat, we all know that, of course, more effort is always needed as the plastic production is always increasing. But I think that it's already, when we see the result and the output of such a work at the end, when the full truck of trash has been collected, I think this is a really positive impact on the global pollution. And for the microplastic, I feel like I've never seen that personally, but I feel like it would be possible to bring people on the beach and at least find a way to collect smaller pieces, such as having sieve. I feel like we could all have sieves and at least collect the plastic that we can visually sort. But I've never heard of any of those.
I'm trying to suggest you to think how we can avoid plastic reach the sea through rivers and so on. So if you have any idea of how to intercept at least macroplastic before being released.
Before they end up in the sea.
Or which kind of human activity can be controlled and checked more carefully to avoid that kind of release or so on. So do you think that is something you would be able to perform or to suggest in some way to the local authorities?
Sorry if I answered of the previous question.
No,
I think that, there are already some initiatives such as the single-use plastic directive that is prohibiting the use of those single-use plastic that are used only one time and then end up in the ocean straight after. So if we would start from the source, we would already limit our consumption. And then in order to avoid then end up in the sea, maybe more research should be done in their transport. And rivers and rainwaters should be also assessed, and beach cleanup could also be done in those areas to avoid that they would end up on the beach.
Okay. So I'm not thinking about some plastic collector, some sort of grid in the rivers or some cleaning of the rivers in the dry season to try to collect the plastic before the release in the sea could be in some way affordable.
Sorry, I think it would be affordable to. That's a question. Like, how would we be able to collect those marine debris on rivers?
Yeah.
Well, I think we should work on the design of this event, but beach cleanup could be done around rivers. Maybe changing a bit the terms. Walking maybe upstreams the river. And organizing people in the sense that we don't miss any plastic litter from down to up.
A last question. I know it's far from your thesis. Are you aware of wastewater treatment plant in Cyprus have been, let me say, updated to try to collect microplastic or macroplastic from the wastewater?
Well, there are a big waste treatment in Limassol, but I actually called them because I was considering adding this asset to the design of my study. But when I called them, first it was really hard to obtain any information about it because they are, of course, saving themselves. And the manager I had on the phone were telling me that there were no... how to say that, no water coming out of the wastewater treatment. So he was actually surprised that I would ask him such a question. It was like saying that there's no purpose of doing a study on microplastics and marine debris around the wastewater treatment, since there's no diffusion, there's no contamination with the environment.
Okay, thank you.
Thank you.
Thank you all for your questions, members of the jury. Thank you, Aurore. We just finished by saying that you've got multiple support from everywhere. From the beginning, you had support at the beginning, as you can see, from a lot of people, including your fellow students, and also some congratulations, including your own lab, I guess. And voila, let's have a look to everyone. By the way, don't hesitate to share your comments. You see, we show them. So congratulations, Aurore, and so see you soon for the next adventures with MARRES.
Thank you.
Bye-bye.
Bye-bye.
So we'll resume the live at 2:45, so in 5 minutes with Clara Cardillo, talking about the impact of recreational snorkeling on sea turtles in Réunion Island. For the members of the jury, please stay here. Okay, here we go. Back for the second presentation. We're on time. We like it like that. So Clara, it's your time. Hello, Clara.
Hello.
So remind
Hello,
us
everyone.
where you are. What time is it?
I'm in Réunion Island, and it's almost 5 p.m.
Okay. So you're going to talk about your work there at Réunion Island. Do you have a timer for 15 minutes?
Yes, I have one.
So if you tell me you're ready, you can go.
Okay.
We don't see your presentation. Okay.
Can you see it now? Okay, good.
And it's all right. Yes.
Is it okay?
Yes, we even see your laser pointer. It's all good. Enjoy.
Okay, good. Thank you. Hello, everyone. Thank you to be here on this MARRES Symposium. So today I will present mine about juveniles Hawksbill turtles behavior in presence of user in Saline Lagoon in Réunion Island. This was made with the center Kélonia. So as you may know, oceans are one of the largest economy. They provide goods and services. And today we have to consider tourism because it will become the largest ocean economy by 2030. And the megafauna is particularly targeted by this tourism through the marine wildlife tourism, which is a form of non-consumptive tourism focusing on the observation of marine species and habitat. Due to their flagship position and habitat share with humans, sea turtles are particularly subject with the turtle watching, which is watching them free in their natural habitats. This consideration is a good thing because they are all threatened on the top of the IUCN Red List with numerous threats such as pollution, bycatch, boat strike, human pressure on priority habitats. So today there is an attractive touristic potential about the turtle watching, and it is promoted to be an awareness-raising tool for sea turtles conservation and their habitats. So our study takes place in the Aegean Ocean, and more particularly in Réunion Island, which is in the western part. It hosts 5 species of sea turtles: loggerhead turtle, olive ridley turtle, leatherback turtle, green turtle, and hawksbill turtle. The first 3 species are offshore, so on the coast we only find the green turtle and the hawksbill turtle. This one is the most endangered of the species, and since 2014 we can see visible recruitment of juveniles on the coast of Réunion Island. According to different species, this is the most prone to disturbance as it shares coastal areas, and especially juveniles because they have sedentary lifestyle, so they are long-term resident population and they experience more tourism. According to different stories, the turtle watching has different benefits, such as generating economic opportunities and implement people awareness, but negative impacts have already been shown, for example, on the natural behavior, on individual physiology, on habitat fragmentation, and population viability. So the problematic was to study the disturbance of hawksbill juvenile turtle by users in their growing sites in Saline Lagoon, and we hypothesized that disturbed turtle will see their swimming time increase significantly to avoid disturbance. So the study takes place more precisely in the commune of Saint-Paul in the Marine Natural Reserve. We have Saline Lagoon. So the study area extends from the Lux Hotel in the south to the Hermitage Pass in the north. We have a very low bathymetry with less than 2 meters and various environments with various substrates and species such as scleratina and hard corals, soft corals, dead coral debris, corallimorphs, algae, sponges, and sandy substrates. But why do we choose this study area? Few reasons. So first, in La Réunion Islands, hawksbill juveniles are spotted on fringing reef, and 50% of them reside in Saline Lagoon. So monitoring are already put in place, such as photo identification with the citizen science program and Argos tagging. Also, this place is very popular, so now it is recognized to be a place for the observation of marine turtles by users, and few papers already show human pressure on the environment, for example, coral abrasion. So this is shared by turtle and by users. So what did we do? The protocol was set up in 2 phases. First, there is an experimental phase. So from the 9th February to the 15th April 2022, snorkeling excursions were carried out during weekends, and holidays in pairs. So it was from 7 a.m. to 7 p.m., 2 hours minimum and 2 hours before the high tide. So we began with random transect in the study area, and when the turtle was spotted, we began the monitoring, which is called a focal. A focal is based on the breathing cycle of the turtle. So the breathing cycle began with the downhill, which is a descending phase, then an activity phase on the bottom, the rising from the surface, and the respiration. And the new inspiration of the turtle starts the next cycle. So we tracked the individual for 10 breathing cycles when it was possible, and during this time, we collect data, individual variables like time of observation, GPS waypoint and tracking, size estimation, initial and ongoing behavior which was filmed all along, photo identification. And also environmental variables, the type of substrate, interaction with humans, the distance, activity, and attitude of humans were collected, and intraspecific interaction, so between 2 sea turtles. So the second part of the protocol was the data analysis. Individual identification was made with the tortue marine du sud-ouest de l'océan Indien. This is a recognition software which used the scale of the face of the sea turtle to identify them. Then we watched the video, and behavior were classified. So downhill, which is a descending phase, swimming, the movement, researching the turtle lay on the ground, move slowly and look at the bottom, feeding, vigilance, the turtle stops its activity and scans the environment, resting, which is a motionless behavior, rising, so toward the surface, breathing at the surface, and finally, interaction between 2 sea turtles. We also counted the number of inspiration and the number of flipper flapping on the videos. So the first goal was to characterize the population structure, to have a better idea of what's going on in the Saline Lagoon. So a total of 44 random transects were made, representing 58 focal and 523 cycles. Concerning the individual identification, 70 observations were made, 60 of them were identified, 10 were not, representing 5 focal. So on the 53 focal, we identified 9 Hawksbill turtle and 1 green turtle, and they were already known on the torsoid database. Concerning the Hawksbill turtle, because this is the population we study, we classify 7 individuals in class 2, so less than 60 centimeters on the carapace. This is the name: Epoy, Audreyne, Mano, Diwan Anaïs, Chouchen, Ratafia, and Bella Vista. And 2 individuals in class 3, so more than 61 centimeters, Maetis and Atwi. Concerning the geographic distribution, you can see that they use all the study area, but the color squares are mainly here, so they are concentrated here in front of the Hotel Le Lux. The main behavior, observed was feeding, with more than 60% of observation, followed by swimming and researching. Concerning the human presence, they were present on 264 cycles, or around 50%, representing around 1 person or 2 per cycle. So with the first result, we have the confirmation of a young resident population of juveniles Hawksbill and the presence of humans of more than half of the cycle of observation. So the next question was, okay, do we have any influence of humans on natural behavior? So to know that, we first compare the cycle briefing. So you can see here, we make a difference between feeding and swimming. So the presence of user in dark gray and absence of users in light gray, and according to the size class of sea turtles. So what we can see when we look at the value distribution around the median is that it's not really different, even if the cycle briefing is a little longer in presence of human. So to be sure about that, we use a statistical test. This test gives us a value, and if the p-value is above 0.05, then we don't have any significant differences. So we did this, and the p-value is above 0.05, so the cycle briefing does not differ in presence and absence of humans. Then we compare all the behavior. So you can see here the mean time of behavior in presence and absence of users. So if we look at it, we can see there are not really big differences, but we use a test to be sure about that. And for feeding, researching, surface, and swimming, the p-value was above 0.05, so we don't have significant differences in presence and absence of user. But for vigilance, it was not the case. The vigilance rate was higher in presence of user. Concerning the flapping flipper frequency, we count it, and in fact, even if the swimming behavior, the time of swimming, is not the same, maybe the turtle move faster in presence of user, showing a difference in the swimming behavior. So we use a test, and the test shows us that the flapping flippers frequency is higher in presence of user. So the first results show that we have a higher rate of vigilance in presence of user, and also fleeing episodes that could induce energy loss on the long term. Okay, so we have a little disturbance in the study, but the next question was to know, is it the same for all the individual, or do we have to consider the characteristic of each individual? So we compared the vigilance rate. So you can see here the vigilance and here all the name of the seal turtle. And what we can see is that MARRES, for example, has a number of cycle in presence of user very high, but the vigilance rate is very low. If we look at all three of us sea turtles, we can see, for example, that Audrey has a number of cycle with user very low, but the vigilance rate is quite the same as Epoy and Chouchet. So it shows that the vigilance rate is not proportional to the number of cycles in presence of user, and that it's not only attributed to user's presence. There are also other factors. Also, if we look at the first date of observation, we can see that MARRES is in the lagoon since more time, so there could be an habituation effect, especially because MARRES has been in the Scalonia Center twice. So yes, possibly there is an influence of individual character, but we need more study to confirm it. So finally, what the study show? First, we have a cohabitation area between juvenile hawksbill and users. The juveniles use this habitat to grow. They select prey until sexual maturity. And we have an attraction of the site because we have different sizes of sea turtles. The turtle watching is also well implemented. Concerning the influence of humans, there were no difference in breathing time significantly. But if you remember, the breathing cycle time was a little higher in presence of user. In fact, few studies show that sea turtle avoid the surface and extend diving time to avoid disturbance. Also, we have no difference in vital behaviors like feeding, researching, and swimming, but a higher vigilance rate and higher flapping frequency. In fact, this is the first response to disturbance, but it doesn't have any impact on other behavior. Studies show that, in fact, there is a crescendo response to disturbance. In a repeated harassment could increase the avoidance behavior. So the first response is the vigilance, and the last is the fleeing and the abandon of the total area. So, in fact, the turtle put its energy in avoidance behavior instead of the survival, and it can be a problem, especially for juveniles, because they need serenity to grow. So it could have an impact on the physiology on the longer term. Finally, concerning the influence of the individual's character, the vigilance seems to depend on factors like distance, attitude, more than just the presence, and it can be also attributed to personality type. Studies show that we have different response to disturbance according to the character of the turtle, if she's, for example, shy or bold. And for example, we have the MARRES example here. There can be also a possible habituation effect. In fact, few studies show that more the turtle is exposed to human presence and more she tolerates closer approach. So it depends on the time of exposure, experience, and personal characteristic of the individual. So to conclude, our hypothesis is not verified. Disturbed turtles are not swimming more significantly to avoid disturbance in the Saline Lagoon. But we have to keep in mind that behavior can change. Now we just have a little disturbance with higher vigilance rate. Also, it is very important to consider in the study a little biais, our presence in the water that could influence the behavior of users when they saw us. This study emphasized the need to continue raising awareness among users To ensure a good cohabitation in the lagoon, we recommend to continue to monitor this population, setting up mediation like it was made on the beach, on the area, and a good communication about sea turtles approach, because even if you look at the turtle for the first time, a good approach can make a better tolerance on the turtle. Thank you for your attention. I would like to thank the jury, the MARRES program, Stéphane Sisson, my director, for this opportunity, and Claire Jean for her help, all the people of Kelonia for their good vibes. I would like also to thank a lot all the people that helped me on the field, and especially Jérémy and my binôme Paola on this study. And finally, I would like to thank once again sea turtles, because they continue to amaze me and amaze people. And I hope that we will do all the best in the future to protect them. Thank you.
Thank you, Clara. Thank you for your presentation. We can open the floor for the jury as we ended with Robin and Christina. Maybe you would like to start, Robin, for example, then Christina.
Thank you, Clara, for the presentation. So I really enjoyed reading your thesis manuscript. It was very well written and very pleasant to read. So
Thank you.
I was happy to read it. I have a few questions. I'm just going to ask the like two, and so to leave space for the other, and we'll see at the end. Has it been observed before that a new spawning site, or at least the presence of new juveniles, occurs somewhere, like it happened with the juveniles of Hawksbill in La Réunion? Because from what I understand, there was no juveniles seen or spawning before 2014, and so the juvenile just came back. Does that happen? I mean, did they come back, or they just appeared? I mean, they were spawned there and down there.
In fact, a long time ago, there was a big population of sea turtles in Réunion Islands, but they were all decimated because they were consumed. And the juveniles were already present before 2014, but we only really observed them since 2014. And thanks to the Torsoy database and the citizen science program, we can better look at them and better see their presence in the lagoon, in fact. But they were present before, but since 2014, they are more coming, in fact.
Okay, and how do you explain? I don't know if it's like the egg and the chicken. I don't know if it's the same for the turtle and the hotel, but how do you explain that all the turtles are like observed in front of the hotel, the Luxe Hotel? Is there any link, or I mean, what do you think?
Yes, in fact, I don't know if you can see. This is the main nutrition of sea turtles in the lagoon, and in fact, they eat a lot the corallimorph, and the corallimorph is present in good quantity in front of the Hotel Le Luxe, because there is the coral debris, and the corallimorph grow under the coral debris. So this is why they are all concentrated in this zone, in fact.
And do you know if there's any restriction or something with the lights from the hotel, or if that has any influence as either attraction or repulsion from the hotel, from the lights at night, because the hotel seems to be like on the beach?
Yes, but in fact, here we talk about sea turtles in the water. So the lights don't have any influence. It's more about the egg laying when they go on the beach. So in the water, it's okay. And in fact, juveniles in the lagoon, they don't stay any time in the lagoon. They go a little sometimes, so they go more far away, and they're coming back in the lagoon to feed. So no, the light don't have any influence about it.
Do you know what they do at night?
They take some nest at night, so it's more nocturnal behavior, and feeding is more diurnal behavior. So this is why in the study, in fact, we observed a lot of feeding behavior and not so much resting, because it's more at night, according to different studies. Yeah, but so it could be interesting to follow sea turtle for 24 hours, for example, to see all the behavior. But it was not possible because I can stay in the water 44 hours.
Okay, thank you.
Thank you.
Thank you, Christina. Do you have questions?
No, indeed, I do not have question because I didn't read the thesis, so I only get some impression from the presentation of Clara. So congratulations for your presentation. And indeed, my only curiosity was the same of a colleague. So do you have any other explanation in addition to the presence of the preferred food nearby the hotel for the selection of this area as the preferred one for the turtles?
You mean what they stay in front of the hotel?
Yeah.
Yeah, so yeah, this is what I explained because there is a lot of corallimorph in this zone.
Yeah,
and,
so the only reason, according to you, because they really prefer that area of the lagoon, the presence of a coralliform.
Yes, and in fact, in the lagoon there is a strong current, and it's so it brings a lot of nutrients, and the growth of corallimorph is is good in the lagoon because of that. And yeah, sea turtles in the lagoon they like a lot corallimorph, but if we look at the feeding behavior in other countries, for example, it can be different. So it depends on the geographic location, in fact.
Okay, thank you so much.
Thank you.
Okay, let's extend so the questions to the jury insights. You would like to continue?
Okay, thanks for your presentation. I have a question about the effect of a higher flapping flipper frequency on the individual lifetime. It is a real stress or a natural behavior because there is a bigger swimmer in front of her?
In fact, the flapping flippers frequency, we must stay critical with that because there can be other factors. For example, if there is a big current, etc. But we observed that sometimes the turtle was disturbed, and so she flew away from the location to go elsewhere. And in fact, the people purchased the turtle, so she went faster to avoid a lot of the disturbance. So this is why I studied for the disturbance, but we must stay critical with this.
Okay. Can you imagine some control site to compare the results? Because it's just one area. Maybe it's interesting.
Yes. In La Réunion, I don't know because Hawksbill turtle are mainly in La Saline Lagoon. But there are also other areas where we can find Hawksbill turtle on all the west coast, in fact, on La Réunion. So it can be interesting to compare it with different zones. But yeah, for the development area of juveniles, I think it's the main of La Réunion. So on the islands, I don't know where to compare it, but maybe on other location or other island, for example, in Seychelles, or there was a study in Honduras, but there were in fact few studies on Hawksbill turtle. Most of the study on disturbance were on green turtle, so it's not the same species. And there were studies on the behavior of juveniles, but not on the disturbance of juveniles Hawksbill. So it was not so easy to compare.
Okay, thanks.
Thank you.
Yeah. So thank you, Clara, for this really nice presentation. I have to admit that, so I've seen these past few years some talk about the turtle study, and I think it's one of the most complete and that I've seen, and I congratulate you for that. It's really, really nice.
Thank you.
So I have a few questions. So it's really curiosity question. So when you score the presence of swimmer and the behavior, and you look at the behavior of the turtle, did you look at, or do you have any info to know if the swimmer is a kid or an adult? And are you planning to see the difference of behavior of the turtle regarding the presence of kids versus adults?
I did not differ the kids versus adults because, in fact, sometimes I saw, for example, an adult touching the turtle and the kid were respectful. So I don't think the age has an impact. But for the next month, I'm still in the internship, and I would like to study, for example, the vigilance according to the attitudes and the distance of observers. So yes, I have to do that, but I don't have enough time before the thesis. But this is planned.
Okay, my idea. I mean, back to this question. It's not with this assumption that the kids will be more harmful for the turtle or more agitated around it, but it's just to see the turtle because of the size of the swimmer or I don't know, something else that the behavior can change. But it's really great that you will pursue it this way. So, do you know if the size of the turtle may influence their behavior regarding the swimmer?
I would say no, because in fact the swimmer and the snorkelers, when they searched the sea turtles, it was like a random meet. Like they were swimming and, oh, I see the turtle, and they stay looking at it. So it depends on if they saw it more than the size.
Because if the turtle, I was thinking that, okay, if the turtle is bigger, do you think that the turtle itself is more relaxed regarding having a swimmer around because it felt more, I don't know.
You mean less disturbance if the turtle is bigger?
If the turtle is bigger, do you know if it behaves differently regarding a swimmer compared to a small turtle?
But you mean the behavior of the turtle, or you mean the
turtle, of the turtle?
Okay. In fact, bigger turtles means that she's older.
Exactly.
Yes. So yes, for example, Maëlys is the bigger turtle of the lagoon, and she's more tolerant. And as studies show that more the turtle experience the human presence, more she is tolerant. We can think that if from their early age sea turtles are habituate, to human presence, and humans stay respectful for the turtle, there could be a good cohabitation in the lagoon. So yeah, there can be an influence on the size of the turtle, but there are a lot of other factors, like I say, the character of the sea turtles, the habituation effects, and the experience. For example, Maëlys, she was twice in the Center Colonia, so she knows the human more than the other turtle. So there are a lot of other factors than just the age, but it counts. Definitely.
Okay. And just last quick question. So regarding this turtle project, so can you envisage to develop a juvenile station in a wider environment with all the information you got regarding the environment of the sea turtle there and the turtle population? Is it possible today to try to develop other sites for juvenile development in a wider area of the island?
You mean study it in another place?
Not studying, but trying to kind of artificially develop a new site where another set of population of turtle or juvenile turtle will develop. Is it possible or not? I know that they are coming back where they are born often, but is it possible? Because here you have a huge anthropogenic pressure on this population. And this population, like you mentioned, is one of the only sites where this type of turtle stay in La Réunion. So to try to prevent the extinction of this site of this turtle and the disruptance, a drastic disruptance, do you envisage with Kélonia, I mean, to develop another site on the Réunion Island where it will be wilder for the turtle, I mean, to do the turtle?
The fact is the Réunion Island is a very new island, so there is no a real lagoon, in fact. This is the only zone when there is the fringing reef on the west coast, and on the other part, for example, in Yugo on the north, there is not a lagoon. There is directly the offshore and for the shark, of course. So yeah, on the west coast, I think it's the only part where they can stay. They have the serenity to feed and grow on the islands.
Okay, thanks. And is there any rules in this specific spot to minimize the interaction of the swimmer with the turtle?
Yes, there is a paper on the beach that talk about the goose approach. And I was for all this internship, I was in binôme with Paola, and she was in charge of the mediation. So first she was in the water with me for not basing the results, and after she made the mediations on the beach. So explain what is a turtle, how to be respectful with this animal, etc., etc. And I think that the raising people awareness, in fact, is the better tool for this subject, I think.
Okay, thank you.
Thank you.
Okay, so I will finish. Thanks, Clara, for your very nice presentation. I have a question because I missed something. How do you measure the human density close to the turtles? I somehow missed that information because at one point you said it's half a person per cycle. And I didn't understand.
You said that. No, not that. Sorry. This one?
Yes.
Okay, so when I was on the fields, I collect the data, so if humans were present or not. And so if in one cycle briefing there was the presence of human, I counted like, okay, here we have a human. Even if it was 1 minute, 2 minutes, or 5 minutes, I counted like cycle with human presence and cycle without human presence. And I just made the percentage here, so this is a little more than 50%.
Okay, so it's presence or absence, but it doesn't tell you that there's 1 person, 15 person, 60 person watching the same turtle.
No, in this study now, I don't consider the number of human presence, but this is what I want to do the next month, to compare the attitude, the activity, if they are calm or agitated, and the number of humans to see which one is has more consequences on the vigilance of sea turtles.
Okay. I think it was very interesting what you said, that your presence may have changed the behavior of the humans. And I think that's very interesting. My question was actually, do you think that your presence and following the turtle throughout the whole cycle may have influenced the behavior of the turtle as well? Do you have any evidence for that?
Alors, so if we saw that we create a disturbance, we stopped the monitoring to avoid that. And in fact, we stay anytime at a good distance to not disturb the turtle. And when you stay a long time with the turtle, because an observation was like 40 minutes, the turtle is habituated at the end to your presence. It's like you're on her environment. So sometimes even the turtle, when really close to us, like 1 meter, and we didn't move. So we try to avoid that.
Okay, thanks. If I may have one last question. In your introduction, you say that turtle watching, there were different studies that sort of showed that there was an effect on behavior and on the physiology, and also on the population fragility. So in your study, it sort of suggests that there may be something affecting the behavior, but not so much. So how do you connect your work to the work that shows that there's an impact? Is it juvenile versus adults? What makes a difference?
You mean why I don't have the same impacts as them?
Yes, yeah, exactly. If you think that there's not the same impact, which it looks to me.
Yeah, I think it depends on the population. It depends on the geographic location. Because, for example, here we have Maïtis, which is really habituated to human presence, but maybe if we study it in other islands, there will not be this habituation. And also, in other study, there were study on green turtles, and for example, a study in Hawaii showed that there was a disturbance and more fleeing behavior, but also that this population was really specific because they were really habituated to human. So when I read all the papers, in fact, there were differences according to the place. For example, a study I think it was in Greece, they saw that the disturbance was different according to the sex, female, male, female during nesting, etc. So yeah, there is a lot of different factors that we have to consider, the age, the location, and stuff like that, I think.
Okay, thanks. So I think it goes back to what Jean-Vincent said. I'm thinking about a control site where you have a similar environment and a similar population without the tourists, without the turtles that could get used to the humans, and then you probably can compare as well. Very interesting. Thanks a lot.
I have just a last possible. Yeah, just a last question about your physical approach of the individuals. Did you come face to face, next to, or other? Because we know that for the cetacean, it's very important the position of the approach to have a better observation. So for you, what was your strategy?
So my strategy was to be in the, I don't know the word, besides, no, not besides, next to it, I mean, sur le côté.
Yes.
And when there were a lot of people, when if they stay in circle around the sea turtles, in fact, she needs an open space if you need. So I always try to be on the same sides as users to not make an encirclement of the turtle, and always stay at a good distance approach, which is 5 meters and 3 meters, but not more. And most of the time, in fact, it was the turtle that came to us, next to us. So it was really amazing.
Okay, thank you.
Thank you.
Thank you. I don't know if someone would like to ask a last question.
So in your report, you said that the proportion of time spent feeding and swimming largely differs from other studies, in particular in Brazil. How do you explain that in particular the feeding time was much higher in the Réunion? And do you think, how do you explain that?
So first, the feeding time is more a journal behavior, and the snorkeling excursion was from 7 a.m. to 7 p.m. So it was all during the day. So first, this is the first thing. The second thing is that in all the other study, the depth were more important. So usually it was like 5 meters, 10 meters. Here we are only 2 meters of depth. So they don't need to swim to go to feed. They are really close to the surface. So this is why the swimming behavior is really different. And yeah, finally, the lagoon is not really. I mean, my study zone was really was not so big. So yeah, usually we spotted the turtle when she was feeding, and sometimes we follow turtle and that they leave the lagoon, so they were swimming. But yeah, most of the time it was feeding behavior. In fact, as they are juveniles, they really need to feed to grow, and especially with corallimorph, because the energetic quality is not really big, so they need to eat a lot corallimorph to have enough energy.
And do you think that they spend a lot of time feeding, and there's quasi systematically people in the water around them? Do you think there could be some habituation of the juveniles to the presence of human, and so that compared to other studies, they can also spend more time even in the presence of human around them? And
yes, there is that, and there is also the fact that in the lagoon they don't have any predators because there is not a shack of ridging reef in La Réunion, so they can be disturbed by any predator. So there is also this to take in consideration. So they can feed a lot and they don't have to be careful or swim to other locations to avoid the predator, etc. And also, I think there is a lot of habituation effect in La Réunion because we saw it on the field. And even sometimes for my thesis, there were like 10 people around and she was just feeding like, okay, it's normal. So yeah.
so it's a perfect spot for them.
Yeah.
Thank you, both. So thank you everyone for your questions, and so Clara for your presentation.
Thank you.
Usual, let's have a look to the comments. You had some, of course, good luck from some of your colleagues, and congratulations from your colleagues, but also from people you might know around. I guess it's not wash hands, but some clapping hands. And from so enjoy La Réunion. It's a fantastic place there.
Thank you.
Really lucky to visit you at some point during your internship.
Yeah,
So,
yeah, it was really good.
Enjoy. We are now doing a break, so 40 minutes, and coming back at 4 p.m. here with the two last happy speakers, Angela and Megan. So we're talking about using beers from kelp in education. That's going to be nice with Angela. And we are going to talk about Mesophotic zones with Megan Bryce, hopefully because Megan is on a research boat under the pole, and we hope that the connection will work. See you in 30 minutes. Bye-bye, Clara.
Thank you so much. Bye. Thank you.
Bye.
Okay, I have to say we love it, this video. For the last time, so we are back here for the session 5, Human Insight in Ocean. For the two last speakers, Angela and Megan, time to welcome you, Angela.
Hello, everyone.
As for the whole afternoon for everyone, how are you and where are you and what time it is?
I am great. I am in the Caribbean in St. Martin at the moment, and it is 10 a.m. for me.
Okay. Just to tell you that we have the sound is a little low. I don't know if you can get closer to your microphone.
Is this a little bit better?
Yes, I think so.
Okay, great. I can hold this up for the presentation.
Good. So if you're ready, just to check it, you have a timer of 15 minutes, you know?
Yes. 15
minutes and then 20 minutes of questions. I guess you followed the presentations before, so I will not reintroduce the jury who is ready as well. And here we go. When you're ready, I'll let you share. I'll let you just put your presentation on the screen and I will put it on the live.
Can you see my presentation now?
Yes, it's good.
Excellent.
Enjoy.
Hello, everyone. As I was introduced, I am Angela Cumming, and today I will be presenting on marine resources as a sustainable path to fund ocean education. I will be focusing specifically on the innovative case of brewing beer with Saccharina latissma to support an ocean education program in Ontario. Thank you to my mentors, Aldina Miel and Christophe Imbert, as well as the University Côte d'Azur and the MARRES program. This project consisted of many components and included a feasibility of an ocean education business in Ontario, as well as the feasibility of producing seaweed beer in Canada. The link between these two projects was determining if a brewery can develop seaweed beer with sufficient profits to fund marine education. Today, due to time constraints, I will be focusing on the feasibility of producing seaweed beer in Canada with a technical, environmental, and economic component. I'm available to answer any questions about the other components of this project, and this presentation will follow the typical structure of a scientific presentation, but the results and the discussion will be linked for each of these feasibility sections. I also have an appendix at the end of my presentation for the question period. UNESCO has deemed education about the environment to be necessary for a sustainable future. In particular, marine education is beneficial for the environment and the economy, as shown in previous studies. However, available marine programs have a high cost for participants, and they are often limited in availability and offerings, particularly in non-coastal areas. Sourcing funding for these programs can widen the availability of programs, particularly for low socioeconomic classes. Marine resources, such as seaweed, could be a solution for funding these programs. Therefore, the purpose of this study is to examine the feasibility of utilizing marine resources to fund ocean education. More specifically, the aim is to assess the economical, technical, and environmental feasibility of sustainable harvesting of seaweed to use in the fermentation process in brewing beer. This will then be determined to see if there are sufficient profits to fund marine education. Traditionally, beer is brewed using barley as the fermentable input to produce ethanol. This project will focus on using Saccharina latissma, commonly known as sugar kelp. This is a species of brown algae that contains storage carbohydrates known as mannitol and laminarin. This is the equivalent of starch in lamb plants, and this is what is fermented in the beer brewing process for ethanol. Sugar kelp also contains structural carbohydrates known as alginate, and these are the equivalent of lignin and cellulose, and these are much more difficult to ferment. This species of interest was chosen for many reasons. Firstly, it can be cultivated from seaweed farms on both coasts in Canada, showing its wide availability. This species has also had previous success in multiple fermentation studies and has been proven to produce bioethanol in the past. As a beer ingredient, it can be unique, gluten-free, climate positive, and beneficial for health due to the many bioactive ingredients present in sugar kelp. Sugar kelp has also been previously utilized in seaweed beers in Canada and the US as a flavor component, which shows the potential for the brewing industry. The methodology for this project will consist of three components. Firstly, there is the technical feasibility. This was calculated as the required amount of sugar kelp for one batch of 5% beer. These calculations were conducted based on previous fermentation studies and the yield of ethanol from sugar kelp. The environmental feasibility is a carbon footprint analysis on the production and transportation of sugar kelp. This is following the methodology of previously conducted analyses in the brewing industry and is compared to barley-based beers to determine if it is more environmentally feasible to use sugar kelp. Lastly, the economic feasibility is calculated as the cost per can of seaweed beer, and this is compared to the cost per can of traditional beer using barley in the literature, and this will determine if sufficient profits are available to fund ocean education. The results and discussion will be combined for each of these three sections. Firstly, the technical results were based on some assumptions about seaweed ethanol production. The first assumption is that the carbohydrate content of sugar kelp is 50% of its dry weight. Secondly, an 80% conversion ratio of these carbohydrates to ethanol was also assumed. Based on these assumptions, the fermentation of seaweed yields 0.24 liters of ethanol from 1 kilogram dry weight of seaweed biomass. With these assumptions in mind, it was calculated that 205 kilograms of dried seaweed is required to produce one batch of a 7-barrel tank of beer at a 5% alcohol level. When compared to barley-based beers, this 205 kilograms falls in the range for barley batches of beer as well. Overall, it is technically feasible to produce a seaweed beer from sugar kelp with sufficient alcohol for consumers. There is possibly a higher carbohydrate content available. The calculations assumed a 50% carbohydrate content in the dry biomass. However, other studies have made use of the structural carbohydrates found in sugar kelp, which would make it more like a 70% carbohydrate content. This would mean that there is more ethanol available and a higher yield, and less sugar kelp would be needed to produce one batch of beer. These studies made use of bioengineered enzymes, however, and these may be more difficult for a brewery to acquire in their production. There is also much more to beer than just the ethanol production, such as the foaminess, consistency, stability, preservation, and flavoring, and so further experimentation needs to occur to assess how this quantity of sugar kelp would impact these components on beer. Breweries may also have processing considerations, such as shredding the kelp before placing it in the barrel, and this would aid in the machine processing. Regarding the environmental results, the first aspect of the carbon footprint analysis is the production of the product. So for seaweed, this included the seeding, cultivating, harvesting, and drying into a dry product of sugar kelp. When compared to the barley-based beers, this is the agricultural aspect in the production. All the units here are displayed in grams of carbon dioxide equivalents for carbon emissions. Sugar kelp has a lower carbon footprint compared to previous analyses on barley-based beer. There is a range for sugar kelp production, and this is due to the different methodologies employed by seaweed farmers. The analysis displayed on this slide is the upper limit of the carbon emissions for sugar kelp production. When assessing the transportation aspect of transporting sugar kelp from the production site on both coasts of Canada to a brewery in Ontario, it is still shown that sugar kelp has a lower transportation carbon footprint compared to two previous analyses. Overall, the production and the transportation of the carbon footprint of sugar kelp for brewing beer in Ontario is lower than that of the two previous carbon footprint analyses found in the literature of barley-based beer. Overall, although sugar kelp does have a lower carbon footprint in beer production, these analyses and calculations assume that all other ingredients and processing are the same as those found in the literature. In reality, the ingredients may be slightly different. Particularly, sugar kelp may need to be balanced with higher portions of hops. Hops are a very environmentally intensive ingredient in the brewing process, and this may alter the carbon footprint of sugar kelp in reality. Furthermore, Seaweed farming technology is continuing to improve, and future farming methodologies may have lower carbon footprints than used in this analysis. This analysis does also not include other environmental factors, such as water use and pesticide use in barley production, as well as the carbon sequestration found in sugar kelp. Including these environmental factors would alter the environmental aspect of this analysis. Regarding the economic results, previous literature has shown that a dried kilogram of sugar kelp ranges from $6 to $8 US. For the required amount of seaweed in one batch of beer, this is approximately $3,000 US. If we are calculating based on one 16-ounce beer, it is approximately $1 US per beer. In comparison to barley-based beers, seaweed beer would cost between 69 cents to $1.33 US more per 16-ounce beer compared to using malt barley for the same purpose. Overall, seaweed is a more expensive ingredient in the brewing process, but previous willingness to pay studies have shown that consumers will pay more for a sustainable beer. Literature has also shown that breweries have donated a portion of profits in previous aspects or campaigns to environmental campaigns, so this may show that a portion of profits are available for ocean education funding. Draft and bottled beer have high profit margins, and so breweries are able to take a smaller portion of profits for good causes or donation purposes. Overall, it is theoretically feasible to produce seaweed beer in the technical, environmental, and economic sense. This project does have a few limitations, however. Firstly, there is more involved in the beer production, and this project is currently at the theoretical stage. A proof of concept and experimentation need to occur to determine the impacts that a large quantity of sugar would have on a beer product. Furthermore, seaweed beer is a relatively innovative field, and so there's not much published in the literature on this topic. This project relied on news articles and brewery websites for a lot of information regarding the current seaweed beer market, and this only tells a portion of the story due to trade secrets. However, for future perspectives, breweries do have high profit margins, and they have shown to be socially responsible and create impact in their local communities. Because of this, there may be an opportunity to make use of a marine resource to fund ocean education. The next step in this project are to begin with smaller quantities of seaweed and gradually experiment with larger quantities upon success of each batch. In conclusion, this project is the first to establish that a seaweed beer could help fund marine education. This project could also help provide inspiration for future ocean education operations to seek sustainable funding from other marine resources. Thank you to my mentors again, Aldine O'Neill, Christophe and Bert, and the University of Côte d'Azur and the MARRES program. I also want to thank my 2022 cohort for their support along the way. Thank you for listening, and I am available for any questions.
Thank you, Angela. Thank you for your presentation and for the exact time. So, as you mentioned it before, Aldine Daniel was part of your coach, supervisor, I don't know exactly how to say, for this type of work. So Aldine will not be part of your jury and will not ask the questions directly.
Okay.
Maybe at the end, not part of the jury. So that's why I open the floor to Christina, Robin.
I start first.
Yeah, go ahead.
Okay. On a perdu. Okay, thanks for this presentation. I have a question about if you redoing, I don't know it's a good word, but redoing this study, what would you change?
If I were to redo this study, I think I would try and include a proof of concept in this study to determine the consistency and more of the experimentation process of the other components of the beer. I've been in contact with a couple breweries to discuss it, but I myself have not done the proof of concept. There's a lot more to brewing beer. As I started to do this project, the chemistry is very difficult, and it is too much for me to take on, but I think I would contact a local home brewer to do a little bit of a proof of concept and source some seaweed for it.
Okay. And did you notice some biases in your study or in your analysis? Or
sorry, can you repeat that?
Did you see some biases?
Oh, a bias in the study?
Bias, yes.
Throughout my study, it was mostly calculation based. So it was making use of previous literature and the results from those. So I didn't personally have much bias, but I suppose when looking for example, previous carbon footprint analyses, I looked at ones that were widely available. And if I had looked maybe at a wider range of beers that weren't exactly barley based, I might have gotten different results. So choosing, I suppose, like a wider range of previous carbon footprint analyses might have altered my results a little bit.
And did you imagine an experimental point of view of this kind of study?
Sorry, can you repeat that?
Did you imagine an experimental point of view, not just literature? Or
if I were to do an experimental point of view, I think it would be to experiment with different quantities of sugar kelp, but as well include kind of the control of the barley as well. So have several trials of the seaweed beer, but do the exact same protocol with barley beer as a control to ensure that the process is the same. Since barley beer recipes are very widely known, it would determine that the methodology is correct and then determine if seaweed is producing sufficient alcohol.
Okay, thank you.
I continue. Hi, Angela, thanks a lot. A very interesting, different project. I have a few questions, actually. At the beginning, you mentioned that there are some elements of the sugar cap that are beneficial for health.
Yes.
How do you know that? And two, do you think after fermentation, you maintain the health benefit?
I am currently working for a seaweed company as well. So I've learned a lot about different seaweed and bioactive ingredients along the way. Sugar kelps and the kelps in general are used quite frequently in a lot of health products and food products due to their bioactive components. And the literature on this is quite extensive. Regarding the fermentation process, there are definitely some changes in the chemical content of the beer or of the product, sorry, and that would also need to be determined if it is possible. One of the things that I found throughout my research is that the iodine content in the sugar kelp it remains as you do the fermentation process, and so a high iodine level may be an issue. With some of the components remaining the same, there is possibilities that the bioactive components could also remain the same. And so I think with a proof of concept, the positive health benefits would also need to be tested after the fermentation step.
Okay, and sort of a related question about the content. At the end, it's important that the beer has a good taste. So do you think that, here again, the same question, but in terms of taste, so I don't know, I never tried the sugar kelp to eat and even less to drink. So do you have any hints on that?
It is currently being used for flavoring in several areas around the world. There are places in the States, Canada, and Scotland that are making use of kelp in beer for flavoring. So it creates kind of a salty, umami flavoring that can be balanced really well with like a darker stout style beer. Okay. So there is a little bit of offsetting that happens, but that is using a much smaller quantity. So with a large quantity, it may be more difficult. And so less sugar kelp may need to be used, and something like rice or barley would maybe need to also help to offset the very salty, heavy sea flavoring of sugar kelp.
Okay, then concerning the price, you said that it might be a little bit more expensive to produce a beer from the sugar kelp. So do you have an idea what the price range currently is between the cheapest beer and the most expensive beer that might be the most ecologically friendly? How do you fit into this? And then the sort of related question, what do you think can you add on top of this or not to get money for your educational programs?
Yes, I didn't go into too much detail in the economic aspect here, but typically beer costs approximately $3.50 to $4 for a beer produced from a brewery. So with that, it costs about $1.28 to produce a beer. So there's a high profit margin based on these. Breweries typically have about a 75% profit margin for bottled, and then even higher for draft beer. With such a high profit margin, there's definitely a portion of profits that can be used. And previous studies have shown that consumers are willing to pay even more for a sustainable beer than a barley-based beer, for example. With that being said, the onus of cost of the higher seaweed product could be put on the consumer in this case. So there could be either a portion of profits from the profit margin or from the higher cost that consumers are willing to pay. Previous breweries, for example, have donated $1 per beer sale to environmental campaigns. And so it shows that it is possible to take part of the profit margin and provide it to external campaigns. With combining that with consumers paying even more, there would be potentially $1 to $1.50 per beer for consumers for an ocean education fund from consumers.
Okay, that sounds promising and interesting. So
Yes.
I leave the others ask a question, and I hope that for the graduation ceremony you have your proof of concept and that we can have a beer.
I would love that.
May I go on?
Yeah, Christina.
Okay, thank you, Angela. I really like your thesis and I enjoy the reading of your paper. But first of all, I would like to ask you why you really decided to focus on the case of sugar kelp beer and why you didn't take into consideration other possible marine biotech application to fund your educational program.
Absolutely, that is an excellent question. This project began last year through an entrepreneurship class, part of ENOV, where my group developed kind of an ocean brewery to promote ocean education, and the project grew from there. The reason that I didn't focus so much on biotech is that breweries have a very community-focused approach, and they often promote different local organizations, operations, or just really positive things going on in their community. I was hoping to take the community approach to developing help for ocean education and create kind of this circular model where consumers are utilizing marine resources and then it is giving back to the ocean in a sense. With that being said, breweries could hold, for example, like open nights for like a pint of science where you give talks, and this would help to market to the ultimate customers of an ocean education project being the parents of students. So it seems unconventional to link beer with students, younger students potentially in ocean education, but I think there can be a really strong community focus and starting at a really local level through this project.
Okay, sorry. I don't know if I catch correctly, but did you experience some, let me say, contact or working experience in a seaweed farm? Is it true?
I've been running the social media for a seaweed farm. So I've been learning all about the operations and how to communicate those to the public.
And what about your microbiological background? Just before starting with some specific question.
My microbiological background is not very strong. I focus more on the education and outreach side.
Okay, so just for your knowledge, according to me, there are some inaccuracies in the microbiological part, and I suggest you to take care a little bit more on the impact of the microbiome of Saccharina and on the chemical complexity of the carbohydrate composition of Saccharina. Indeed, in one of your slides, you put some of this problem on the dashboard about the enzyme, the possible things. According to me, you have to go a little bit more in detail in this part, in these technological problems. Okay. Not problems, but difficulties that you can experience. Yes.
Yes.
But I have another question for you, and is why you really want to use Saccharina as raw material, and you don't want to use the byproduct of Saccharina application in other fields as raw material for your beer.
Sorry, what do you mean by the raw materials or the applications?
Because Saccharina has many biotech applications for the extraction of bioactive molecules and so on. So I really think my suggestion is that probably you got a good idea, but the best thing is not to use Saccharina as the entire raw material, but
Okay.
the rest, let me say, of Saccharina after you have already extracted some nutritional factors or other bioactive molecules that can be used in other applications. So in a real way to approach the circular economy idea.
That would be very interesting. The previous fermentation studies that I looked at utilized the raw product. So that was kind of my, I suppose, drive for the focus of the raw product.
Yeah,
but it would be interesting to look at the other bioactive components of it as well.
Yeah, because in that way, probably, as you already told us, Saccharina don't have to be the main source of sugar, but it's more for flavoring or other things. So you don't need huge amount of this, but you can really approach in a circular way if you use byproduct of other activity using Saccharina.
Absolutely. I suppose you could supplement the sugar part from rice or from different other carbohydrates or plants out there. That's an excellent thought as well.
Okay, so I really enjoy your presentation, so thank you very much.
Thank you so much.
Thank you, Christina, for sharing also these elements with Angie. Robin?
Yeah, my main question was, is seaweed beer any good? But I see that we're not going to have the answer today.
It's our questions, all of us, I guess.
There are seaweed beers that just use the flavor, and I've had great things about them.
Not
exactly.
The same. I mean, otherwise there wouldn't be no point, like just going for seaweed. But so, as you say, seaweed is just like one of the ingredients for the seaweed beer. I mean, the point is to make it the main ingredient, if I understand. But if we just go back like to the carbon impact of this seaweed beer, what would be the proportion, or like the potential proportion of seaweed for the production of beer compared to other ingredients? And I assume that maybe for hops it works, but you're talking about rice several times. I don't think they grow exactly in the same area. And how would this impact the actual carbon, what do you say? Carbon
footprint, the carbon footprint, yes.
Yeah, carbon product of your beer.
So there were many questions there. I will try to answer them all the best I can. The seaweed would be the main component in this, for example, carbon footprint analysis. So traditional beer has barley, hops, yeast, and water. The barley is always the most plentiful ingredient in the production, and that is what I would be replacing it with. The hops is a minor component that adds a lot of flavoring and bitterness, and usually it is used to offset some other components, for example, in the seaweed. So increasing the proportion of hops would be required, and hops is really often overlooked in carbon footprint analyses in previous literature. For example, the two that I looked at also didn't include pay too much attention to hops. But with that being said, since it is usually such a small quantity, increasing that won't impact the overall carbon footprint in a substantial way. The hops are environmentally intensive to produce, but a small quantity is used in each batch of beer, if that is clear. So a large agricultural growing of hops is difficult, but only about, I think it's 8 grams go into a batch of beer. So it is a very small quantity.
But do hop grow where you can grow the sugar kelp?
I think there are hops that are produced in Canada, but they would be a land agricultural component. So you would still have the pesticide use, for example, and the intensive water use. So it would not be environmental positive process like seaweed is.
But would it be better than using rice in your beer?
The reason I used rice is that rice is a gluten-free example in beer. So there are different things that are made use of, like buckwheat, for example, rice, quinoa has been used, sweet potato has been used. So all of these things could still be utilized to produce a gluten-free beer. But probably the most realistic would be just to continue to use barley, because it is what is commonly used now. So for example, starting with a small quantity of sugar kelp and still a large quantity of barley, and slowly reducing the barley quantity would probably be the most realistic approach to producing a seaweed beer in the future.
It's interesting to know that you can use sweet potato to...
I had no idea until I started this process. During my research, I reached out to a brewery in Seattle that produces only gluten-free beers, so they do not use barley. And some of the ingredients they've used in the past and that they directed me towards were not what I expected.
Yeah, so I mean, if you find the right mix of everything, you can actually like create a very low carbon footprint.
Exactly, yeah. Yes. Especially if you're looking to source local products as well. A lot of times breweries seek barley from local areas like Canada or the States, but also overseas in Europe, for example. So trying to seek Canadian ingredients could lead to a much lower carbon footprint as well, particularly in the transportation sector.
Yeah. Thank you.
Thank you, Robin. I don't know if the jury here has a question.
I have a question, but I'm not 100% sure if you didn't answer this already. But I didn't understand why you say that the transportation has less impact than the other resources, because it's the distance and the weight and not the content that makes a difference, no?
Exactly. So this is very particular to the two carbon footprint analyses that I did look at that source their ingredients from much farther away than their local brewery, for example. I was focused on sourcing this sugar kelp from Canada specifically, but if it was sourced from the US, for example, it would contribute to a higher transportation carbon footprint. Since the carbon footprint in the transportation does make up a large portion of the sugar kelp or the seaweed beer carbon footprint, I did want to still include it. Those were kind of the main aspects that changed. If I use the transportation carbon footprint, for example, of the previous analyses, it would not show the realistic or appropriate carbon footprint for the sugar kelp.
Okay. And then I had another question. So here you use seaweed from a farm, which is already interesting for whatever economical interest. Do you think that you can apply this kind of approach to other algae species that are more environmentally impacting, like the Sargassus algae that is sort of invading the Caribbean Sea and stuff like that? And then
that would be a very interesting approach, and I definitely did think about ways that sargassum could be utilized in this aspect, especially because it could help solve a problem like that. I didn't look at the exact carbohydrate content of sargassum, for example, and I don't believe there's much literature on the fermentation of it. There is extensive literature on the fermentation of sugar kelp for bioethanol purposes, and that's why I chose this species. But it would be interesting to look at if there is sufficient carbohydrates in the sargassum and if they are the right carbohydrates.
Okay. I'm good.
Yep.
Thanks.
Sure. So I think that we are good, Angela. So you talked about field of science. It's good because, tomorrow afternoon, the year one students are going to present their immersion project video pitch in a non-formal setting that we like to call also field of science. So, unfortunately, we'll have more conventional drinks, I think.
Yes, I think so.
We've got just a question here from Rita. It has been already asked by Christina Largit why, but in this question you have something more precise. Have some breweries experimented with seaweed beer before? I think you answered that mostly that the seaweed things are in addition to the conventional ingredients. Exactly.
The breweries that I reached out to, they are not making use of the sugars in the seaweed. They're just making use of the flavoring. So they are not altering the amount of barley in their recipe at all. It's remaining the same. So that is where their ethanol is coming from, is the barley. So it would be interesting eventually to make use of the sugars and fully utilize what sugar kelp has to offer.
I think you've got all of us on board for testing in September for the graduation ceremony, and at the same time, so you've got some congratulations. So good luck at the beginning, and then congratulations. Florence is on board apparently also, and so Hilaria too. Congratulations, Angela. I already forgot where you are. Saying something.
I'm in St. Martin. I'm teaching
St.
marine
Martin.
biology. I officially finished, my students wrote their final yesterday. So I'm spreading the ocean knowledge to some students here.
Yeah, Angela is part of the students doing multiple things at the same time, and I want to highlight that. At the same time, Angela, your project is a little bit non-conventional, combining human inside the ocean. It's the title of this session. Combining sometimes so economy into it, engineering and everything. So congratulations, because during these last 2 years you passed a lot of time also abroad, remotely. So yeah, finishing in such good things after 2 years, a lot in special conditions. Congratulations.
Yeah, thank you so much. I really appreciate it. It has been a great journey.
I hope we'll see you for real during the graduation ceremony.
That would be excellent. Thank you again.
Bye-bye, Angela. See you.
Bye-bye.
Ciao, ciao, see you.
So for the last presentation, the presentation of Megan Bryce, unfortunately, it seems that we've got some connection problems with Under the Pole, which is currently, I think, in the Arctic, close to Longyearbyen. So it was supposed to work, but we have no news recently in the last minutes. So what I will propose is simply to broadcast the recording that we asked Megan to do in such case scenario. And after that, we will end the broadcast and we will discuss about questions together. Of course, Megan, you hear us and you can join us in the next 15 minutes. It will be an excellent idea. I will try to add this to the screen.
Because I will be on my work sailing boat.
Here we go.
My name is Megan Bryce. I'm a second year's MARRES student, and I am recording this video in case on the 29th of June I am not available or I do not have internet, because I will be on my work sailing boat in Svalbard, so I'm unsure about the internet connection. So my master's thesis was about the mystery of the Mesophotic Zone, comprehensive synthesis of the state of knowledge and recommendations for conservation of this important yet threatened zone. And it was under the supervision of Gaël Boutier-Guérive, who is the awareness coordinator of Under the Pole. So I will first establish an introduction before going to my materials and methods, leading to my results that I will then discuss and finally conclude and show you my references. So we know very little about the ocean. This vast space that covers more than 70% of our planet remains unknown, so unmapped, unobserved, unexplored for more than 80%. So to date, less than 20% of the ocean floor has been mapped to modern standards. And so beyond this observation, there is another, which is that some parts of the ocean are better known than others. And one of them remains particularly neglected and poorly understood, which is the Mesophotic Zone. So the Mesophotic Zone, from the Greek meso, meaning medium, and photic, meaning light, corresponds to the zone extending from 30 to 150 or 200 meters, depending on the definition, below the surface of the world's oceans, where sunlight still penetrates enough to allow the organisms concerned to carry out the process of photosynthesis. And so it is part of a larger zone called the euphotic or photic zone, which is the superficial layer of the ocean that you can see on this graph. And so the main factor of definition of the mesophotic zone is light, even though other factors have an influence on it, such as sedimentation, temperature, or topography, for example. The definition of this zone is very complicated and not consensual. The word mesophotic only began being widely used in 2000 and even 2008 it was first introduced, and it is mainly applied to mesophotic coral ecosystems, also called MCEs. And there are many confusions in research papers between mesophotic zone, mesophotic ecosystems, etc., but also between the mesophotic zone and the twilight zone, which is the zone under the mesophotic zone. And finally, the definition we gave that does not leave room for the variations that exist in these zones around the world. So a mesophotic zone in the English Channel will not be defined the same way as a mesophotic zone in French Polynesia, for example. So since the definition is based on light, it is moving and depends on several other factors, such as turbidity of water, for example. Either way, we have decided to keep the initial definition of the mesophotic zone we gave to focus more on acquiring an overview of knowledge about this zone. So the mesophotic zone remains understudied, underexplored, and suffers from a profound knowledge deficit. And it is also not considered in decisions, and this leads to a lack of protection. And the reason for a delay in comparison with other zones of the ocean, such as the surface zone, for example, is mainly due to technical difficulties of access. But aspects of this area are beginning to reveal themselves with the advent of new technologies, so such as rebreathing diving, for example, or remote operated vehicles. And we are only starting to discover and understand some aspects of this zone. And main focus has been on the mesophotic coral ecosystems, which actually are only a small part of the zone. Nevertheless, as we learn more, we become more aware of the importance of this zone. And so if we briefly focus on the biology of the mesophotic zone, it is stated by Pyle and Koppes that mesophotic coral ecosystems could account to up to 80% of the world's reef habitats. But we also find rhodolite beds, black coral, octocoral forests, sponge aggregations, so various different ecosystems which have distinct characteristics. So whether it is species richness, functional diversity, complexity, or on endemism level. So we find both depth generalist and depth specialist species. And so some are endemic to this zone. And so, however, while we are discovering this area, we also discovered its threats are also hanging over it and putting its future health at risk. So this master's thesis explores the hypothesis that the mesophotic zone is scientifically understudied, not considered in decisions, and poorly known, and it draws consequences from that. And it attempts, with the help of a global and systemic view, to understand the reasons for this lack of knowledge. And however, it nuances by explaining that there are reasons for hope and formulates recommendations for a better protection and consideration of the mesophotic zone in research, but also decision. And so the aim of my thesis was to establish an exhaustive synthesis of the state of knowledge of this zone to date, but also to draw conclusions and recommendations. And so for the context, I am currently in charge of a awareness raising and educational mission in the Under the Pole program, which explores the mesophotic zone. And it seemed essential to me to provide all those interested in the mesophotic zone with a global vision of the subject. And so my thesis will, among other things, be transformed into a briefing notes and various other tools that will be used to support Under the Pole's work. Coming back briefly on my materials and methods, I use several methods of in-depth qualitative and quantitative literature review. I also developed a survey that aimed to question and assess the knowledge of the mesophotic zone by the public. So for the quantitative method, I conducted this analysis of existing scientific literature, so articles, thesis, etc. So I first compared the total search results for the Mesophotic Zone and for the Twilight Zone using both Google Scholar and worldwidescience.org to compare results. And I then observed the evolution of search results over time using advanced search tools on the same search engines. Regarding the qualitative method, I conducted extensive research and systematic review of papers, thesis and scientific research done so far. And so I looked very closely at 56 Google Scholar results containing Mesophotic Zone in the title, as well as I reviewed 4,190 Mesophotic Zone results in the overall text to try and assess what these writings covered. And so I also used the platform mesophotic.org, which was created in 2008 with the aim to be a repository for scientific information on the Mesophotic ecosystems. And for the review of important scientific papers, I relied on the bibliographic tool Zotero to classify and study them. And so in my research, I was also able to benefit from a collection of documents linked to the work of Under the Pole. Finally, since in our highly connected world, a lot of things go through videos, images, websites, etc., and the general public's knowledge of the Mesophotic Zone is not made or very little through reading scientific articles, I looked at content that is not scientific, that deals with the Mesophotic Zone by using various search engines and classifying the results in an Excel sheet. Now, regarding the survey I built, so I established this survey in the form of a questionnaire to assess the general public's knowledge of the Mesophotic Zone. So the questions were designed to underline or invalidate the thesis presented in this paper. And so I used the Google Forms tool. And so the dissemination was done through different media, so via my personal social networks. It was also on self-service on a tablet at the Under the Pole booth at the Vendée Arctique event, which was a sailing-oriented event in Vendée in France. And so that was on the 3rd, 4th, and 5th of June 2022. And so the global broadcasting took place from the Sunday 22nd of May 2022 to the 5th of June. And this resulted in over 150 responses being collected. Now, if we focus on the results in this section, I reviewed the various elements I found. And as the subject is quite general and overlooking, and most of my research is based on qualitative literature review, my results in this part are related more to the quantitative analysis as well as the survey, but most of the important information, important results are incorporated into the discussion and come from the qualitative research, and I did that for more logic. So regarding the qualitative, very briefly, many scientists agree that there is a real knowledge deficit on the Mesophotic Zone, looking at many different aspects, whether it is biology, connectivity, ecology, distribution. So there's a real lack of knowledge about the Mesophotic Zone. And regarding the quantitative analysis, as we can see in these tables, the Mesophotic Zone is understudied, especially compared to the Twilight Zone, for example, that is just under. However, there has been an increase in research in recent years, and as we can see on the left here, and that's especially since the mid-2000s, when the Twilight Zone research has remained the same through time. And so in addition to results of scientific field research, new tools have been added to the research on the Mesophotic Zone and produced new results that did not exist before. So it's the case of satellite data, for example, that has been increasingly used to study the Mesophotic Zone. And so for results of the non-scientific content events investigation, I found various outreach videos made by recognized organizations such as NOAA, as well as more amateur videos from divers, for example. But in terms of quantity and quality, it is, however, not comparable with the Twilight Zone, for example, there again, which counts hundreds of popularization videos made in such a way that you can imagine that important means have been invested. On the contrary, when we compare it to the Mesophotic Zone. And so quantitatively, 8,410,000 results appear in Google when we search for Ocean Twilight Zone, and only 89,700 for the Mesophotic Zone. If we look at the 151 answers to my survey, it leads us to the conclusion that the general public's knowledge of this zone is poor, and that people know the Twilight Zone better than the Mesophotic Zone. So this is what we can see here too. Moreover, people seem to have guesses about what threats or what the importance of the Mesophotic Zone is, but it is very unsure. And so the discussion section is the one in my thesis that allowed me to really address the complexity of this subject with more of a systemic and societal approach than a very precise subject with laboratory or other experiments. And so the first analysis I draw is that the Mesophotic Zone remains poorly known and studied. And so I try to understand the reasons for this lack of knowledge. And so we do not master all of its biological and ecological structure or processes, neither its connectivity with surface ecosystems or deeper ecosystems or its distribution. And so going into details, we have, for example, difficulty in confirming theories such as the refuge theory, according to which surface species take refuge in the Mesophotic Zone in order to resist changes in their environment. So there are still many unknowns in the researchers' work on the Mesophotic Zone. And so our survey confirmed that. And so the reasons for that are, could be, or are for some, a complex scientific exploration. So scientific inventory and species sampling have historically been based on trawling, on fish catching or on dredging. And even though Darwin had found coral, mesophotic corals at depths of up to 120 meters during the HMS Challenger expedition, so 1873-76. Until recently, the underwater exploration tools did not allow humans to explore the zone in situ, like directly. And so that was until the 1950s, 1960s. There was no real observation, and we only studied species by extraction. And so the first studies of the ecology of the mesophotic coral ecosystems using rebreathers and mixed gas technologies began in the 60s and 70s. And the first ones were in the Marshall Islands, in Jamaica, Cuba, and Hawaii. And so moreover, the exploration of this zone is expensive. And Pyle and I'll explain that there has been very little funding of research, although I struggled finding precise information regarding fundings. And so finally, there is a lack of awareness, and according to researchers, it is a loop. So a lack of knowledge and research leads to a lack of awareness, which in turn leads to a lack of funding for research, and the loop continues and goes on. And there is one nuance, however. One aspect of the mesophotic zone is better studied than the others, and that is mesophotic coral ecosystems. But yet, the mesophotic zone is a zone that is under threat. So as Poglies explains, since mesophotic coral ecosystems are part of a continuum of shallow water reefs along a depth gradient, they are subject to many of the same threats faced by shallower water coral ecosystems. And so there are several threats to the Mesophotic zone in particular. So fishing, with some fishing techniques particularly threatening, such as bottom trawling, for example, but also pollution and coastal development. So a prominent example of this is the Deepwater Horizon oil spill in 2010, which damaged gorgonians in the Mesophotic zone, so at around 70 meters deep, that remained under the oil layer for between 10 and 60 days, and that deprived them of light and killed them. We can also state, of course, climate change, with main impacts being temperature variations, warming water temperatures, acidification of the water, rising water levels, and finally frequency of extreme weather events, because indeed there are also natural threats to the Mesophotic zone. So deep sea ecosystems are not subject to the same threats and pressures as surface ecosystems, but events impacting the surface can cause calcareous debris to sink into the Mesophotic zone. And there are also invasive species such as the flying rockfish in the Atlantic and the macroalgae species such as green algae, Avranvilia in Hawaii that you can see here on the photo. And so these threats are threatening the Mesophotic zone before we even understand its full importance. So, for example, EL and AL estimate that Australia's Mesophotic coral ecosystems are likely equivalent to that of shallow reef ecosystems down to 30 meters. And so the value of Mesophotic zone, the Mesophotic zone, has not been assessed, unlike surface ecosystems. However, although part of the Mesophotic zone may be similar value to the surface zone, it can be assumed that the Mesophotic zone also has its own ecosystem services and is therefore important to assess on its own. So more than a habitat, the Mesophotic zone could be a refuge, as I explained. It is also a transition zone between the surface and the depths, the light and the dark. It has specialized biodiversity. It provides ecosystem services. It is a carbon sink. It also has economic and recreational value, and of course, a symbolic and intrinsic value for itself. And so yet, Mesophotic coral ecosystems are among the last protected ecosystems in the world ocean. Most MPAs do not encompass the Mesophotic zone. They are underrepresented in marine spatial planning guidelines. And so several nations have already made management declarations and started to extend marine protected areas and fishery management to MCEs. For example, it is the case of Elliot in Israel, but this is not what happens most of the time. There are reasons for hope. The Mesophotic zone is increasingly recognized in scientific research, as we observed it earlier on the graphs, for example. And so moreover, new initiatives to support the research and knowledge of the Mesophotic zone were put in place. So that's the example of the platform mesophotic.org that you can go and check. And so this can be explained by various reasons. The international workshop of 2008 on the subject highlighted the importance of focusing on the Mesophotic zone in research, and it's also due to technical advances that push the boundaries of what is possible. So closed circuit rebreathers with trimix, so mixed gas inside, but also, for example, remote operated vehicles, autonomous underwater vehicles, sonars, man-submersibles, acoustics and optical imaging techniques, for example. But there remains some limits. So, for example, there are some geographical disparities in the study of the Mesophotic zone. So Eyal and Al pointed out that research efforts on the Great Barrier Reef MCs are in decline compared to other regions. And so furthermore, although there has been a growth in research on the Mesophotic zone in recent years, it remains much less than research that has been conducted on other areas of the ocean. So this work has led me to the collection and formulation of recommendations for a better consideration of the mesophotic zone in scientific research and decisions, especially in terms of conservation. And so they are based on the logic that better scientific knowledge leads to better awareness, that leads to a better consideration in decisions, and in turn leads to a better protection. And so these recommendations can be taken at different levels, so international, national, and local. And to summarize them, they consist in making the mesophotic zone a priority in ocean conservation, a better consideration in governance, the integration of mesophotic coral ecosystems, mesophotic ecosystems in general in treaties such as, for example, the Convention on Biological Diversity, fisheries management, of course, global direct action, for example, to reduce CO2 emissions, marine spatial planning, marine protection areas, high resolution mapping, or participatory science, for example, with ecosystem observation, monitoring, or restoration. And finally, I believe awareness raising has an important role to play too. There are some limits, of course. It's not just about marine coral ecosystems like it has been until now. It's about protecting the mesophotic zone in general. And that's difficult because of the lack of clear definition of the zone. It makes it hard to add in treaties or others, so it makes it hard to protect it. So there's a work to be done on that aspect. And finally, of course, whether it is marine spatial planning or marine protected areas, it can be something that is expensive and difficult to control with for example, the problem of paper MPAs that we know. However, I have an example of a organization that acts to better protect the mesophotic zone. So this organization is called Under the Pole. It's an underwater exploration expedition I work for. And so this expedition dives in the mesophotic zone up to 175 meters in all oceans, so polar, temperate, tropical. And so it has been studying different aspects of the zone. So their next program from 2017 to 2020 was a Deep Hope, and it dove on mesophotic coral ecosystems. So it found new species, it discovered species in some places we didn't expect them, and it's also tried to confirm the refuge theory. And so their new program called Deep Life, taking place between 21 and 2030, and is recognized as a UN Ocean Decade official program, dives to study marine animal forests of the mesophotic zone. So that can be either mesophotic coral ecosystems, but also gorgonians or black corals or sponges or bryozoans. And so it is a good example of what can be put in place to better understand and better protect the mesophotic zone. So to conclude, it is urgent to improve the knowledge on the mesophotic zone in order to better protect and conserve this essential yet neglected and threatened zone, which plays a vital role in the balance of the ocean and the planet in general, and which is not fully understood yet. And so the mesophotic zone should be considered as a natural heritage for mankind and must be protected to avoid declines in biodiversity and therefore catastrophic consequences for the ocean and us. And so it is now a matter of closely following the efforts put in place, such as the Under the Pole program, and of acting in favor of better scientific and decision-making consideration of this area. So I invite you to have a look at my references, and I really hope that I am with you today. And if I'm not, I am probably trying to connect to the internet the best I can. So I hope you will be able to ask questions. Have a good day.
Thank you, Megan, but unfortunately, I guess it will be difficult to ask questions because the connection is still impossible with Megan. So it's a bit unconventional to say it, if we do finish the session on this. So we will also end the live here, and we will stay with the jury to see what we do with that. Thank you for having followed us during this 1 day and a half. I would like to thank a lot the jury of these 2 days, but also, and maybe I won't take above all, but maybe I could say that to my team. Thank you a lot, Juliette and Christelle. It has been the most smooth symposium of this last years, and it's a lot thanks to you. Merci beaucoup. Thank you to all. Donc le jury, stay here, okay? Just finish here, and because we like it, just finish with the video. Robin, Christina, hold on. We're coming back just after.